Hello everyone, welcome to Basic Calculus. I am Nancy and today we are going to talk about a question from this year's free response question under non-calculated section. And this question is about derivatives and antiderivatives. We're given a function f on a point f negative 2 equals 7 and also the graph of its derivative. So before we do any of the following questions, I'd like to first find the area under the curve, because the area under f prime of x would help us get the other values on the function f graph. So we can divide these into three sections. On the left side, the triangle, the area equals 1/2 times the base, which is 4 times the height, 2, and this gives us 4. So this is 4, and then the semicircle, we have 1/2 pi r squared, which in this case the r is 2, and this gives us the area equals 2 pi. And our last triangle, we have 1/2 times the base, which is 3, and the height 2, we get 3. And remember here, because the semicircle is under the x-axis, we need to remember that this is negative 2 pi. And now we need another equation to find part A. So we want to find f negative 6 and f of 5. What we have to recall here is the fundamental theorem of calculus, which is on the right side, and it states that if we have a function f of x and its derivative f prime of x, we know that the integral from point A to point B f prime of x dx equals f of b minus f of a. So here we can find the integral because it is just the area under the curve, and also we know another point which is stated in our question, f of negative 2 equals 7. So let me rewrite this equation into f of b equals f of a plus the integral from a to b f prime of x dx. And so the first one, f of negative 6, we can write it as f of negative 2 plus the integral from a to b, which in this case is negative 2 to negative 6, f prime of x dx. And we know that f of negative 2 equals 7, and the integral, which is the area under the curve, from negative 2, the point right here, to the point right there. And we know the area is 4, but because it's going from right to left, meaning negative 2 to negative 6, we need to do a minus in the front. So our value for f of negative 6 is 3. And then our second one, f of 5, we do basically the same thing. So f of negative 2 plus the integral from negative 2 to 5 f prime of x dx, and this we have 7 minus 2 pi plus 3, and we're left with 10 minus 2 pi. So our answer is 3 and 10 minus 2 pi for part A. Now we move on to part B, and we want to find the intervals for which f is increasing. We know that if a function is increasing, its derivative must be positive. So we want to find the intervals for which f prime of x is positive, and we can find it pretty easily from the graph they already gave us. So we have the interval from -6 smaller than x, and then smaller than -2, and also 2 smaller than x, smaller than 5, which are the areas I shaded in pink. This one and this one, we have f prime of x greater than 0. So now we have to justify our answer, meaning that we need to explain it in words. So we say that f has, so we say that f is increasing on intervals -2 smaller than x, smaller than -2, and 2 smaller than x, smaller than 5, because on those intervals f prime of x is positive. And this is all we have to do for part B. And then for part C, we want to find the absolute min of f. There are 2 steps. The first one, we want to find the internal possible points, meaning that the minimum value between -6 and 5. And to find this, we only have to know f of prime of x goes from negative to positive. In other words, f of x goes from decreasing to increasing, so we can have a curve like this. So if we look at the graph again, we know that there is only one point where f prime goes from negative to positive, and I'll circle it in green. So it's this point right here where x equals -2. So to find the value, it's pretty easy here. It's just f of -2, and we can do the same thing again using fundamental theorem of calculus. I'm sorry, that's actually f of 2. And this equals f of -2 plus the integral from -2 to 2 f prime of x dx. And this gives us answer 7 minus 2 pi. And then this is all we have for our internal values. And then we want to check the endpoints. So our second step, the endpoints, which are x equals -6 and 3. So f of -6 is f of -2 plus the integral of -2 to -6 f prime of x dx. And we do the same algebra here and that gives us 3. And again, because we already find the endpoints for part A, we can just copy that down. And then we do the same thing for f of 5. And that is 10 minus 2 pi. So we just copy our answer from part A, 3 and 10 minus 2 pi. And then we want to compare these three answers. And we got that 7 minus 2 pi is definitely smaller than 10 minus 2 pi. So f of 2 is the smallest, and 3 is smaller than 10 minus 2 pi, so it's in the middle of negative 6, and that's smaller than f of 5. So here we can find that our absolute minimum value is at f of 2. So for our justification, we can say that at x equals 2 and f of 2 equals 7 minus 2 pi, f has absolute min because f prime of x goes from negative to positive, and it is smaller than both endpoints, which are negative 6 and 5. And that's all we have to do for part C. Now for part D, we want to find double prime of f at negative 5 and 3. Because we have our f prime of x graph, we want to just look back on it. Screw back up, and what we want is negative 5. I'll circle it in black, which is here, negative 5 and 3, and that's on the top. To find double prime, we can just find the prime, the derivative, or the slope of f prime of x. So for f x equals negative 5, we can use dy over dx. And using 2 points, negative 6 and 2, and negative 2, 0. However, for the point where x equals 3, our f prime of x is continuous but not differentiable, because the slope is not constant. We have a corner at x equals 3. So here we can find, so here for f double prime of negative 5, we will use dy over dx, and that gives us negative 1 over 2. Well, for f double prime of 3, as I said before, it does not have a double prime, or it does not exist, because at that point f prime of x is not differentiable, and because that there is a corner. So this is all we have for this question from part A to part D, and thank you so much for watching. Hope you enjoyed this video.